Hello Legacy students. So today we're going to look at solving exponential equations with a common base. What you're going to have on you is a notebook, writing utensil, that perfect Rutsch chart that you had for the radical functions unit, and then also you might want a calculator to do some simple math for you today. So let's review. Ultimately, you can write pairs of numbers so that they have a common base. So if I have 8 and 32, I can make 8 into 2 to the third, right? Because 8 was equal to 2 to the third. I can make 32 equal to 2 to the fifth so that they have a common base. Ultimately, that's the goal of today, is trying to get two numbers that don't look like one another to have a base to an exponent. So they both have a common base number of 2. If I have a 3 and 81, ultimately 3 is just 3 to the first, right? Now I want 81 to be 3 to some power as well. So if I look on my yellow card here, or my green, yeah, my yellow, I see 81 is 3 to the fourth, right? So they would have a common base number of 3. Same thing, 25 and 125. Well, 25, I know that's 5 squared, and 125, that's 5 cubed. So ultimately what I'm trying to do is see, can I make them equal to one another? And then sometimes ones that look absolutely not like one another at all, you have to make them match. So 1/7 and 49. Well, I know 49, right, is 7 squared. This is just 7 squared. So I need to somehow come up with 7 to some power has to give me 1/7. Well, how can I get 7 to be 1/7? Well, that just like flipped, right? So that 7 moved down to the bottom. You know what? I bet it's 7 to the -1. That will give me 1/7. So if you go from a normal base to a fraction, assume you're always going to have an exponent going on in there. Those are probably the hardest ones to figure out. So a method for common bases. If you see a variable in the exponent, you need to get the bases the same if possible, and then set the exponents equal to one another. So let's try a couple of examples here. I got 5 to the x equals 5 to the fourth. So notice, guys, they do have the same base. They're both 5. So honestly, I really do not care about those bases anymore. All I care about is setting the exponents equal to one another. X does in fact equal 4. Let's try another one. So 4 to the x equals 8. Well, 4 to some power is definitely not 8, but what I'll do is make these both match in base. So what base do 4 and 8 both share? So I'm going to follow the rows and see, well, under the row of 2, I have a 4 and an 8. So this 4 is technically 2 squared, right? That's technically what that is. And 8 is technically 2 cubed. So if I multiply these exponents, because it's a power to a power, so if you remember our properties of exponents rules, that's 2 to the x, or 2x multiplied. Now I'm at same base. I have a 2 and a 2, so now all I have to worry about is my exponents. So 2x equals 3, and divide by 2 on both sides, so I'll get x is 3/2. Let's try another one. So I got 3 to the x plus 2 power equals 9 to the x. Well, I need to get a common base, right? Well, 3, I can't do 3 squared, right? Because 3 squared is not equal to 3. Be very, very careful with that, because you see, well, 3 squared is 9. But that's making more than what you have over there. So I have to keep 3 as 3 to the first. Okay? But I can make 9 into 3 squared, right? Because 3 squared is in fact equal to 9. That's why I'm allowed to just, basically I'm just rewriting the number into a new form. So this is technically 3 to the x plus 2 over there, and 3 to the 2x. So if I solve, I'll get x plus 2 equals 2x, or 2 equals x. Ooh, quite a bit more here. 81 to the x plus 2 power equals 27 to the 5x plus 4 power. Well, I need to look at my green card here. What row do 81 and 27 both show up in? Looks like 3, right? So 3 to the 4th is 81. And 3 to the 3rd is 27. There we go. So now what I get to do is multiply my exponents. So this will be 4x plus 8 and 15x plus 12. So now I'm going to set my exponents equal and do some solving. So 15x plus 12 minus 4x. 8 equals 11x plus 12 minus 12. So 8 negative 4 equals 11x divided by 11. So it looks like x will be equal to negative 4 over 11. Definitely not a nice number, but definitely the answer. If I'd plug that into both of these, you would see that the answer, 81 to whatever power that may be, that would be a number equal to whatever number you get over here as well. So if you do want to check your answer, it's not required, but if you want to check to make sure you get the right answer, you could definitely plug back in and make sure you get both sides equal to the same amount. And let's try this one. So I got 9 to the 2x plus 1 minus 2 equals 25. Very first thing I notice, can't have that. It's kind of just hanging out there. It's like that lonely guy that's just hanging there. So let's get him to the other side. So I'm going to add him over. That's going to give me 27. Now I need to make these numbers with a common base. I do know that 9 times 3 is 27, but that's not what I need, right? I need a common base to an exponent. So I'm going to look on my card here, and it looks like under the row of 3, 9 and 27 both show up. So I can make 9 into 3 squared, and I can make 27 into 3 cubed, right? So that means if I distribute that 2 in to that exponent, 4x plus 2 is equal to 3. So x is 1/4. So then I have 7 to the x minus 1 power equals 1 over 343. So just like I mentioned earlier, guys, if you have a fraction, because it looks like 7 is going to be our common base, because nothing times itself gets you 7 except 7 to the 1st. And I look on my green card here, my yellow card, I notice that 343 is 7 cubed, right? So then this itself, that's not 7 cubed though, that would just be 343. But since it's a fraction of 1 over that number, what I can make this turn into is 7 to the negative 3 power. That's equal to 1 over 343. So if you get a number that is a power of a certain base, but it's on the bottom of a fraction, you have a 1 on the top, that means that you can just use a negative exponent to get to that number. So right over here, got a same base, so I know x minus 1 equals negative 3, so that means x is negative 2, which would make sense, right? Negative 2 minus 1, that would be negative 3. And with that, that is the end of this video. I will see you later, Sabers.